Voyager 1, the farthest human-made object from Earth, is once again transmitting useful information after months of incomprehensible data. This legendary spacecraft, currently drifting about 14 billion miles away, was launched in 1977 and contains less computing power than a modern kitchen microwave. As of February 2025, Voyager 1 is a 167.35 astronomical units from Earth, so distant that it takes more than 22 hours for a signal traveling at the speed of light to reach us. In recent months, scientists monitoring the probe began to notice something unusual. Within the steady stream of telemetry data, researchers detected patterns that seemed anything but random. Some experts believe that these signals include structured sequences, mathematical in nature, suggesting embedded complexity, well beyond what Voyager was built to produce. The anomalies reportedly include sequences of prime numbers, subtle shifts in universal constants, and even the impression of a three-dimensional spiral when the signals are analyzed in specific ways. The key to these findings may lie in a new advancement in quantum computing. Microsoft recently introduced a revolutionary quantum processor named Majorana 1, which uses an innovative topological core architecture. Unlike traditional systems, this processor has been able to detect underlying structures in the Voyager transmissions that had gone unnoticed. These patterns are so mathematically precise that some researchers question whether they could be the result of natural error or random noise. While major news outlets have remained largely silent on the matter, smaller specialized communities are buzzing with theories and speculation. The situation raises profound questions. After nearly half a century, how is this aging spacecraft? Originally designed to explore just Jupiter and Saturn, now transmitting data that some argue exhibit signs of intelligent structure. Those who have always looked beyond the surface are already paying attention. The idea that a probe launched in the late 1970s could be involved in one of the most significant anomalies in scientific history is as fascinating as it is mysterious. To understand why these signals are drawing such intense interest, it helps to revisit Voyager 1's legacy. The spacecraft began its journey on September 5, 1977, and has far outlasted its initial 5-year mission. It entered interstellar space in August 2012, becoming the first human artifact to leave the Sun's protective bubble. Today, it continues to communicate with Earth via NASA's Deep Space Network, transmitting weak signals on frequencies of 2.3 and 8.4 GHz. Its signal power is barely 23 watts, no stronger than a refrigerator light bulb. By the time these signals reach Earth, their energy is less than what a single bacterium uses to move. Voyager's technology is remarkably primitive by modern standards. It runs on just 68 kilobytes of memory and was programmed entirely in assembly language. Its electrical power comes from a plutonium-based thermoelectric generator, which is expected to keep at least one scientific instrument running until the 2030s. Over the years, the probe has experienced several malfunctions. In 2022, corrupted data was traced to misrouted information from a non-functional computer, which engineers fixed a few months later. In late 2023, another issue affected Voyager's flight data system, once again halting science operations. NASA solved this by April 2024, restoring normal function. It's against this backdrop of aging hardware and previous glitches that the current signal anomalies have emerged. Critics argue these are likely more technical issues. Nothing new for a spacecraft that has already shown signs of wear, but others claim this time is different. They argue the mathematical precision in recent transmissions exceeds what could be explained by hardware failure or corrupted code. The role of quantum computing is central to this unfolding story. On February the 19th, 2025, Microsoft unveiled Majorana 1, the first quantum processor built on a topological architecture inspired by theoretical physicist Majorana. The processor features 8 qubits, with the potential to scale up to 1 million. Researchers in the quantum field suggest that unlike traditional computers, quantum processors can simultaneously examine multiple possibilities and patterns, allowing them to detect structures hidden deep within noisy or incomplete data. The timing of Majorana 1's debut closely coincides with the emergence of the unusual Voyager signals. Some believe the signals always contained these patterns, but it took a quantum leap in computing power to finally uncover them. According to those studying the data, Voyager's recent transmissions include several distinct anomalies. One is the appearance of the first 10 prime numbers in sequence: 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29, embedded in what should have been random signal noise. Additionally, universal constants like Planck's constant and the fine structure constant reportedly appear with a minute but consistent variation of about 0.013%. Perhaps even more striking is the alleged discovery of a spiral structure, revealed only when the signals are analyzed using quantum algorithms. This spiral reportedly aligns with Fibonacci sequences and the golden ratio, patterns found throughout nature, but highly unlikely to arise from mechanical noise in a decaying spacecraft transmission. Another puzzling feature is the presence of the number 127, which has deep significance in digital computing. The number appears in the form of 127.0.01, commonly known as the loopback or home address, a way for computers to refer to themselves. Some analysts interpret this as a kind of digital self-reference embedded within the signal, something Voyager was never designed to do. Validation of these discoveries remains an ongoing process. Multiple quantum computing teams using different systems have reportedly found the same patterns, lending some weight to the idea that the anomalies are not just observational errors. The search for extraterrestrial intelligence has traditionally relied on analyzing radio signals or flashes of light, but this new approach, using quantum processing to reanalyze legacy signals, could open an entirely new frontier. Whether these signals represent a breakthrough or just an unexpected quirk of aging technology, the questions they raise are deeply significant. Could we be witnessing the first indication of contact? If intelligent patterns are truly embedded in Voyager's transmissions, how do we interpret a message encoded in math, rather than language? And even if this turns out to be a false alarm, what does our curiosity say about our drive to understand the cosmos? Humanity's exploration of the universe has barely begun. Each new tool, from radio telescopes to quantum processors, brings us one step closer to insights we couldn't have imagined just a few years ago. And sometimes, a 48-year-old spacecraft drifting through the darkness reminds us that the answers to our biggest questions might already be out there, waiting for us to know how to see them.